All right, so good afternoon, everybody. My name is Jesse, and I am with Exploring by the Seat of Your Pants. We're an organization committed to bringing science, adventure, and conservation into classrooms around the world. So today I am particularly excited because we are joined again by the Arctic Institute of North America. Over the last few months, we've been doing an epic program series with them, highlighting some of the amazing things going on in the North, highlighting stories of culture, conservation, changing ice conditions, and more. So it's exciting to continue that series today, broadcasting live both to the Exploring by the Seat of Your Pants and the Arctic Institute of North America channel. So today we are joined live in Colorado by Dr. Mark Serres. He is the professor of geography at the University of Colorado Boulder, an institution that does a great deal of work to promote and understand climate conditions around the globe. He is also the director of the National Snow and Ice Data Center. And today his talk is going to feature talking about the farewell to the Arctic of old. So he's had a front row seat over the last 4 decades to changing conditions in the Arctic. He's going to explain the story of how he came to understand the Arctic is changing and what the modern day Arctic means for people and wildlife and beyond. So thank you so much for joining us today, Dr. Serres, and take us away.
Well, thank you everyone for having me. It's real exciting to be here. So yeah, farewell to the Arctic of old. That's how I've titled this thing. But what I'm really going to tell you here is a story. And it's a story of the Arctic, which I'm telling you from the perspective of really my own journey through, basically 4 decades of research now, as someone who was actually once a skeptic on the issue of climate change, but as scientists should do, who finally awakened to the reality of our changing climate when the data, when the evidence became so overwhelming. A few years ago, I published a book on this story, Brave New Arctic, The Untold Story of the Melting North. I didn't come up with the title. It sounded a little Aldous Huxley-ish to me, but I guess it really tells this whole story. And of course, there's a lot of updates, a lot of things that have happened in the past 3 years. So yeah, it's a story of then when I was a young grad student in the Arctic for my first time to where we are today and where I am today. So every story has a beginning. And the beginning to my story is back in 1982. In 1982, it was still pretty much an analog world. Oh, there were computers around. I was using them myself, big bulky things. But for most of everyone's lives, most people's lives, it was very much an analog world. I put that poster from E.T. That's when the movie E.T. came out, right? So that kind of tells you where I'm coming from. But I was a senior at the University of Massachusetts in Amherst, not Amherst College, ZooMass as they called it, big state college. And I had taken a couple of courses from this guy, Ray Bradley. Now, he's a famous climate scientist, still doing a lot of work on paleoclimates as well, climates of the past. And he'd been involved in Arctic research for a number of years before I even met him. He was an associate professor then. And he saw that I was taking these classes and that I seemed to have an interest in what's going on in the North. And he said he needed a field assistant for work on Ellesmere Island in Arctic Canada. And so, well, I volunteered, of course, being a young guy wanting some adventure. And I also applied to the graduate school. And by miracle, it turns out I was accepted. I had no idea I would be, but I was. Maybe Ray had something to do with that. In any case, it was off to the Arctic, and that was in basically May of 1982. So this is just a shot of the camp that we had, looking out to some more, more somewhat snow-free hills out to the back. So, but here we were on northern Ellesmere Island. And I was this enthusiastic cub scientist. As Ray called me, a cub scientist. I wasn't really a scientist. I was a science wannabe, so kind of a cub scientist. But what I was doing there, and this was part of my graduate work then at this point, was to test how these 2 small ice caps on the Hazen Plateau of Ellesmere Island, that's in the Canadian Arctic archipelago, were affecting the local climate. So what we did is we set up a number of instruments on these 2 little ice caps. You can see them here. This is an aerial photograph from 1959. Here are these 2 little ice caps, and we were putting up instruments at these sites like Zebra out here called Uniform, another one called Yankee, both on and off these 2 little ice caps. And the idea is we would compare the data from the sites on the ice cap, like from this Zebra station to Yankee. And the idea in doing that is through those comparisons, we could get some idea of how these little ice caps were actually affecting the local climate. Of course, it's much colder over the ice cap than it is over the snow-free land. The albedo, what we call the reflectivity, is of course much higher over the ice cap than over the land. But the idea is to really quantify these things. And why we were doing this was coming from this. Is Ray Bradley, one of his first papers he ever wrote, had noted, this was back in 1972 when he wrote this, that this climate warming trend observed since the 1880s seemed to have given away since the 1940s to a cooling trend, most marked in the higher Arctic latitudes. So we've been warming up, then we started to go into a bit of a cooling trend. Now, as we know now, that was a fairly minor blip. Okay, in the temperature record, but a number of people took notice of it back then. And there was even some discussion in the science community. It was certainly greatly pushed by the media that could we be entering a new ice age or something like that. So here you see the cover from Time magazine, How to Survive the Coming Ice Age. It turns out this is a fake. It's a fake. I'm not sure who did it or who did it when, but it is kind of emblematic, or it really describes some of the thinking at that time that we could be entering this cooling phase. So the idea, well, maybe this inspires this study that I'm doing, because what I was doing was looking how these little ice caps were affecting the local climate, and maybe that could be scaled up. And it comes back to these ideas of a feedback that, well, if we have a snow and ice cover, like on one of these little ice caps, and the climate cools a little bit, maybe some of that snow survives the summer. So next year, there's a larger area with this bright snow and ice cover reflecting more of the sun's energy away, furthers the cooling and so on. And that's how we could kind of initiate an ice age through what we call feedbacks. And so that's why I was doing on those two little ice caps, was kind of doing a local test of these ideas that had been put forth about how ice sheets might be able to quickly grow, get us into a new ice age. But of course, this temperature anomaly, this little blip we were seeing, turns out to have been kind of just a little blip, but we'll get to that later. Now, we had a lot of fun up there. It was a little rough at times. There's our tent in the background. We use that for both just hanging out, after a day's work and for cooking. And we use just a Coleman gas stove for both heating and cooking, just run with white gas, one of those 2-burner Coleman stoves. People thought, well, people asked me today, well, weren't you afraid of something like carbon monoxide poisoning? And my answer was, back then, we didn't worry about things like that. We didn't even talk about things like that. But on the other hand, the tent itself was rather well ventilated, so I don't think we had a problem. And we would sleep in these little tents like you have on the right. But we tried to maintain some sense of civility. There I am actually making bread. And in these Coleman ovens, you can actually sort of cook them as an oven. It's not worked very well, but we tried. It was an interesting place, a very different era of field work back then. Back in 1982, it was pretty much the Twin Otter aircraft drops you off with some food and some fuel and a 2-way radio and says, see ya in 10 weeks or whatever it was. So decidedly not like we see today with GPS and all that. Now, some of you who may have been doing field work earlier than that might say, oh, Suarez, you had it easy then. You have no idea what it was like back when I did field work. Agreed, okay? But it's all relative. But it was just a really cool place to be on that ice cap. Nasty weather, of course, that we'd endure. Here we're in the middle, kind of a whiteout blizzard. You see an anemometer in the background, which I was trying to get some estimate of the wind speed from. The thing is, these little ice caps we were on were at about 3,000 foot elevation, around 1,000 meters, something like that. And everyone else's low-level stratus down at sea level was our ice fog. So we had just constant issues with fog and with rhyming on the instruments and things like that. So it was certainly an interesting place to be. Well, I got a little more experience in 1983 being the field assistant of Fritz Koerner. Fritz Koerner, Canadians may recognize him. He's a very, very famous Canadian glaciologist, worked for years and years and years. And I got to be his field assistant in the spring of 1983. And what we were doing is looking at the mass balance of a number of glaciers and ice caps across the Canadian Arctic. And so we'd go and fly from one place to the other, do a series of measurements for a few days, fly to another one. The guy was just completely impervious to cold, absolutely impervious to cold. Amazing fellow, Fritz Koerner. I was not impervious entirely to cold. I learned all about frostbite. You see, I'd had this one field season in the Arctic, and I thought I knew everything. I was 22 years old, thought I knew everything, of course, right? Then they put me on the top of the Devon Island ice cap, where it was about -40 with a good stiff breeze, and I realized that I really wasn't prepared for this. Well, live and learn. So now whenever I go out, I make sure I'm fully prepared. So we learn our lessons hard. I had this girlfriend at the time, and I came home after this and my skin's peeling off my face and off my fingers. I thought I looked cool. I was like the Arctic explorer. She wouldn't go near me for 3 weeks until I healed up. But it was an experience. Well, all right. We went back to these ice caps in 1983 and the next summer. And one of the things we did was put in this big network of stakes, aluminum stakes. You stuck them in the ground. You drilled a hole like you see on the right, and then you take these aluminum stakes, stick them in the ground. And the idea of doing this, putting in this stake network, was that we would be able to monitor the mass balance of these little ice caps, whether they were growing or shrinking. Basic idea, you take this stake and you measure how much stake is showing and how deep the snow is. And you do that 1 year, and then you come back the next year and do it again. If more stake is showing, basically the ice cap lost mass. If less stake was showing, basically it gained mass. There's a lot more to it than that, but more or less that's what it's all about. So we put in this stake network, and here's my old field notes actually showing the outline of this larger of these two ice caps, kind of that heart-shaped one I showed before, and these different stake networks we put in. So a couple years went by, and spring of 1985, I eventually published my master's thesis on this work we'd done. It's called Topoclimatic Investigations of a Small Subpolar Ice Cap with Implications for Glaciarization. It was the idea of testing the local climate. And we were also doing this mass balance work. The intent was that, hey, we'd go back year after year and measure this stuff, and I never went back, right? Life got in the way. I went on to try and get a doctorate, and I never went back to those ice caps. But those ice caps that I spent so much time on and knew every nook and cranny, they're gone. They died. Now, what I'm showing here are these two ice caps as outlines of the extent of these two ice caps. The first one on the outside on the blue, that's 1959. And that's when these aerial photographs were taken. Here's the little one as well. Well, we were able to acquire various satellite imagery, and also my colleague Ray and some of his next generation of graduate students had gone back to the ice cap. In 2001, they did a GPS survey around the perimeter, and here it was. It had already shrunk. Now, I kind of knew this was happening, but it was just kind of in the back of my mind. But then it was really, a while later, I said, let's take another look. And so we got a hold of some higher resolution satellite imagery for 2014. There's the outline in green. 2015, there it is. And it turns out in 2015, these things had shrunk, both of these ice caps, to about 5% of their original size, what we had in 1959. We went back and looked at satellite imagery for last summer. That would have been the summer of 2020, and they're gone. They're completely gone. Nothing left of them. And when I realized that these ice caps had gone, had disappeared, this is kind of when climate change became a personal thing to me. We think of ice caps, right? I always thought of ice caps as a permanence. These are permanent features. We're going to go back year after year, and there they're going to be. Maybe they'll grow, maybe they'll shrink, but they're going to have some permanence to them. And to realize that they would disappear over the sense of 40 some odd years was just astounding to me. But this is really characteristic or emblematic of the things we've seen happen across the Arctic. So yeah, my little ice cap's gone. A drop in the bucket in terms of sea level rise, but it became very personal to me. I kind of thought of them as my ice caps. I say there, they were actually the Canadian government's ice cap, and I thought they were mine in a sense because I knew them so well, every nook and cranny. So now let's go ahead and look at where we are today. Just briefly look at where we are today. Well, the Arctic has warmed up so strongly. There's something called Arctic amplification going on. This is from NASA, and this is an analysis of the change in surface temperature over the period 1960 through 2020. And I'm showing the annual average change. Now, the globe has warmed up. Global warming, of course. Now, some places have warmed up more than others. A few places, like here in Antarctica, that aren't warming yet, actually still cooling a little, but certainly the globe is warming up. But if you look at where the colors are the warmest, where? The Arctic, right? I think a lot of us understand this. We recognize this. It has a name called Arctic amplification. Interestingly, this is something that was predicted way back at the end of the 19th century by Svante Arrhenius. And he attributed this to these ideas of feedbacks. As the Arctic loses its snow and ice cover, that bright ice cover, more of the sun's energy can be absorbed, which makes it even warmer. There's a lot more going on Arctic amplification than that, but that's one of the drivers. But the Arctic is basically warming at something like 3 times the rate of the globe as a whole. Arctic amplification, here we are. Well, what are some of the indicators of that or results of that? Now, certainly the ice cover is shrinking. Of course, this is the floating sea ice cover on the Arctic. I'm looking here comparing September 14th of 1984, kind of towards the beginning of the satellite record, started actually in 1979, and where we were on the right in the middle of September in 2012. And it's pretty shocking. We've lost something like 40%, something like that, of the ice cover in September. When will we lose the rest of the ice cover? In other words, when are we going to go ice-free at the end of summer? Who knows? But the numbers are converging on maybe 2040, something like that. But a remarkable loss of ice cover. Now, the thing is, this is a response to the warming, of course, because it's getting warmer, so you're losing the sea ice. But it's also a driver of the warming as well. Because again, as we lose this ice cover, the ocean now, the dark ocean, can pick up more solar energy, pick up a lot more heat, releases that back to the atmosphere in autumn and winter. So the sea ice loss is both a response to the warming that we've seen, but also a driver through these feedback effects. Other things we've seen, coastal erosion, a growing problem, especially like on the north coast of Alaska. The very strong coastal erosion, areas that are eroding back 15, 25 feet per year. Now, what's happening here? There's a kind of a triple whammy going on in that, first of all, there's not as much sea ice as we had anymore. So now you go in September or something and you look north of Point Barrow, there's no sea ice for hundreds of miles. But there used to be stuff much closer to the shore. Well, now that means that waves get bigger because you've got a bigger fetch over open water. But the water is warming, itself is warming. Why that's important is these coastal bluffs are glued together by permafrost. And so with warmer ocean waters, there's basically a thermal erosion going on as well. But at the same time, the permafrost itself is warming. So there's kind of a triple whammy going here on the coastal erosion. Thawing permafrost in general, starting to have some big effects. Here's a couple of photographs from around Fairbanks. And you can see what happens when you start to lose that permafrost. You can get radical changes in the landscape. Here's what's happening to a road. This is somewhere around Fairbanks. A couple of summers ago, before the pandemic hit, I was up around Yellowknife, Canada, on an effort to look at where some of the sporadic or relic permafrost might be in that area. There was supposed to be some there, but boy, we searched long and hard before we found anything. A lot of what was there and had been mapped previously, like from the International Permafrost Association, is no longer there. But we're seeing a lot of this across the Arctic, and it has impacts on infrastructure, as you can see, and on the landscape. Now, the Greenland ice sheet melting down, right? We know that's happening. The Greenland ice sheet is losing mass and contributing to sea level rise, as are Arctic glaciers and ice caps. It turns out that the contribution to sea level rise recently from Arctic glaciers and ice caps is actually bigger than from Greenland. But of course, Greenland has a big potential for sea level rise. And so these are all contributors to the rise that we see in sea level. And of course, this is not statistical or anything. This is what we actually observe, right? No fake news here. All right, so that's where we are. When did it all start? When did it really begin? And so here we have this next section here, or the next part of my talk is the Arctic stirs. This is a shot from north of the Brooks Range. I was doing some work with guys from UAF up here, Matt Sturm and others, doing some snow work. So it was a beautiful sunny day, kind of rare up there, but it was a nice time. All right, let's think of where we were around 1990. I just got my doctorate, starting to do some work. And all right, we had this 1960s cooling, I remember, right? That inspired some of Ray Bradley's work, but there was still growing acceptance that the climate was going to warm as we load the atmosphere with greenhouse gases. The physics seemed pretty solid on this. And we figured that we'd really see it strongly in the Arctic because of these sort of feedback processes that I talk about, that if we warm it up a little bit, we melt some of that snow and ice cover, which is bright, you absorb more of the sun's energy, and so on. But even by 1990, when this first report from the Intergovernmental Panel on Climate Change came out, right, the first IPCC report, the evidence for change was not all that strong, and especially in the Arctic. This here, I'm showing you a map of the temperature change going from 1957 through just about 1990 from the data we had for the Arctic back then. Warm colors is warming. Cool colors is cooling. Your geography, here's Greenland out here, here's North America, here's Boulder down here where I'm from, okay, and so here's Russia along here. So red is warming, blue is cooling, but what did we see? A mix. It's just a mix. I mean, you look at that, can you say, well, is really things warming up? I certainly couldn't. It was warming in some areas, but the Arctic was cooling in others. And that was consistent with what we would expect from plain old natural climate variability. And what I mean by that is things like shifts or changes in patterns of atmospheric circulation that bring in warm air from one area, bring in cooler air to the other. That sort of natural variability is what I'm talking about. That's what it looked like, I think, to a lot of us. And what were the views in the science community? What were people in the science community saying? Well, Jim Overland of NOAA is a longtime colleague. He's been doing Arctic climate research since the 70s. And when I interviewed him on this, to write my book, he said in 1991-92, we did not see or think much about Arctic changes. It was all about variability. Marika Holland, well-known climate modeler at NCAR, just embarking on her career at that point. And she says she really wasn't thinking too much about Arctic change, and it just seems so distant, something far off and far away. That was where a lot of the thinking was in the community. Well, around that time, I was learning the ropes. I was now a young scientist at the University of Colorado Boulder, where I still am, working in the field with Canadian graduate students, and we were doing work out on the channels of the Canadian Arctic archipelago near Resolute Bay. For those of you who may have been there, we were set up camp on a little place called Griffith Island, 20 kilometers out. But we do our work out on the ice cover, and doing all kinds of things, measuring surface energy balances, measuring ice thicknesses, all kinds of things. At the evening, we'd have time for a little golf, right? We'd paint the golf balls a bright orange. Pretty good form. I think that's me, actually. Pretty good form for a place like that. We'd actually play out on the ice as well. Boy, you could take a 9-iron, the thing would go half a mile, I would swear, right? But we were right, of course, in Polar Bear Alley. So one was hitting the golf ball, the other one with a shotgun was watching out for polar bears. It was quite interesting. And there's certain things about Canadian grad students, stereotypes that are true. For example, you should never go out drinking with Canadian grad students. I've tried several times, and I have regretted it both times, right? And all right, so we were out there doing some work, and we weren't thinking about climate change or warming, and in fact, it was the last thing on our minds, and certainly mine. Because we were out there in the spring of 1982, and what had happened is that Pinatubo, right, Mount Pinatubo had erupted. And we had, as a result of that, basically a summer without a summer, at least in the Canadian Arctic. It just never warmed up, never even really had a melt season. Now, we'd been there the year before, 1991, and we got there in 1992. You could see it was different. You could even see in the sky that it was different because of the aerosols from the volcanic eruption. That was the last thing on our minds, that, the climate was going to warm up. We're like, come on, And then in 1983, I was part of this paper published in Nature where we were looking at radiosonde data and looking at temperature trends throughout the Arctic atmosphere, what we call the troposphere. And here's a quote from that paper. "We do not observe the large surface warming trends predicted by models. Indeed, we detect significant cooling trends over the Western Arctic Ocean during winter and summer." Where's the warming, right? Where's the warming? But things were starting to stir. And some of this, the first evidence came from a cruise of the Russian icebreaker Rossiya in 1981. And as a German oceanographer, Detlef Kodfossil, he noted this slight warming of the Arctic Ocean's Atlantic layer. Now, what this is that if you look at the Arctic Ocean, there's a fresh, cold surface layer. And underneath that, there's a warmer, saltier layer that represents the inflow of waters from the Atlantic, and is called the Atlantic layer. Well, he compared temperatures of that Atlantic layer from earlier data that had been collected with the recent data that he'd collected as part of this cruise of the Rossiya. And of course, this is right after the Soviet Union had broken up, and found that it had warmed. Now, he was the first to say in this little paper that, hey, this is just one set of observations. It may mean nothing, but it bears watching. That's basically what he said. Well, there were other hints of change as well. John Walsh from University of Alaska Fairbanks, and probably a number of you know him. Some of you may know him. He, in a paper, showed evidence, and this was from the growing satellite record we had at that time, that sea ice extent was starting to decline in summer, broadly consistent with what he was calling warming. But as I noted, the pattern of temperature change still then was still very regional, areas of both warming and cooling. It still looked to me like natural variability. Yeah, sea ice was starting to decline, but was that just due to some regional warming pattern? It wasn't clear to a lot of us, but it was still another hint that things were starting to stir. Well, then the plot starts to thicken. This is just a shot from right around Barrow. There's a big shore ice heave there looking out back in 2008, a while ago. Well, what happened was that Atlantic layer warming was confirmed. There was data collected by the Swedish icebreaker Odin, the USS Pargo, that's a submarine. And you can see on the bottom there's a submarine surfaced. And other research cruises, they confirmed that ocean layer, that Atlantic layer, was warming. And the Arctic now seemed to be stirring in other ways. Paleoclimate evidence, John Overpack, well-known paleoclimate scientist, they did a study, and they concluded that, and this is a 1997 paper, that the late 20th century Arctic temperatures were the highest of the past 400 years. And their explanation is that this is best attributed to the observed increase in carbon dioxide levels. So here we were looking at these temperature changes, and warming in some areas, maybe cooling in some areas, and it was confusing. But then when John looked at it in a longer term record, he was saying, really, despite the sort of variability we see, it's still really warm compared to what we've seen over the past 400 years. So it just started getting people thinking about what was going on. And this paleoclimate evidence, this is from lake cores, from ice cores, pollen analysis, all kinds of things. Now, of course, there's uncertainty in paleoclimate records, as there are with any observational record or any record in general, but it got people thinking. More evidence, thinning of the sea ice cover. Drew Rothrock, University of Washington, he compared submarine sonar data collected between 1993 and 1997 with earlier records. Now, the submarine sonar data you've had for a long time, submarines going under the ice cover. In the U.S., the first cruise was the Nautilus back in 1958, and it carried an upward-looking sonar. It really wasn't, they didn't have it there so that people could say later, crazy scientists could say, well, we're going to use it for sea ice research. I believe back then it was primarily a safety feature. In case they had trouble, they could find a place to surface. But from these under ice sonar records, you can get ice draft. That's the part that sticks under the water. And from that, you can get the ice thickness. So here's an analysis of the ice draft that they made. Whoops. Between this later period in the red and the earlier period here in the blue. And these are just comparing these two periods. And you can look at it, but just look at around the North Pole. Back in back in the day, right, a mean ice draft, 4 meters of ice, something like that. Whereas these later records were saying, oh, maybe less than 2.5 meters. So the evidence for change was really becoming stronger in both the atmosphere and the ocean. But was it still an issue of just like shifting wind? Jim Hurl, a young climate scientist at the National Center for Atmospheric Research, he did an analysis of atmospheric patterns. And he found that nearly all the cooling over Northwest Atlantic, that was out here, and this warming across Europe and downstream over northern Eurasia, which we had been seeing, was really resulting from changes in something called the North Atlantic Oscillation, basically a pattern of what we call atmospheric variability, the NAO. Now, later studies put this in a different framework called the Arctic Oscillation, and but really is kind of the same thing. But the argument was that, well, there's been a shift in these wind patterns associated with a shift in the North Atlantic Oscillation, or what we call the Arctic Oscillation. And this overall warming, this tendency we're starting to see towards warming, toward decreasing ice thickness, towards some loss of sea ice extent, it's just a shift in the wind pattern. So no need at all, right, to invoke the satanic gases, as they would say. Might it be that this shift in the winds was itself a result of increased greenhouse gas concentration? Somehow it wasn't clear at all, but still it made it very unclear just what was going on. There was all kinds of confusion, I think, in the community. And I was sitting on the fence. If you look at a paper I published in the year 2000, looking at all the evidence of change that we had in the Arctic, looking at sea ice, atmosphere, all kinds of things. We published a paper with a number of well-known scientists, John Walsh, Terry Chapin, some permafrost people. It says right in the abstract of this paper, taken together, these results paint a reasonably coherent picture of change, but their interpretation as signals of greenhouse warming is open to debate. It wasn't clear. But that changed. And there was an epiphany, if you might say, an awakening. More than natural variability. I remember telling myself, if this NAO, North Atlantic Oscillation, and AO regress from their high positive phases, the ones which was consistent with warming, and the Arctic continues to warm, and we continue to lose sea ice cover, in other words, without that sort of atmospheric boost, I'll be starting to convince that this is something more than just natural variability. And it was right around 2003, looking back at my old notes that I write to myself, things like that, that's when it happened. That's when it became clear to me that it was more. And then it really became rude awakenings. 2007, we had a new record low in sea ice extent in September, not just beating the old record that was set 2 years earlier in 2005, but blowing it away. And I recall through the summer, as scientists from all over the world kept looking at the satellite data day after day and seeing these big chunks of the ice eaten away. We'd never seen this before. And I think that, it was very much a turning year, 2007, when so many of us in the community realized that it's kind of a new Arctic now. We're not going back. There's something very different about this now. It was an awakening by so many of us of the changes that we've seen are just really remarkable. It was really a turning point for many of us. Arctic amplification. Here's the figure I showed before, which was, it turns out it was 1957 through 86. Here's that pattern that we saw in the annual temperature change. Warm colors warming, blues cooling. And that's the pattern we saw, that spotty pattern. Here's what now, if you look at it later, 1987 through 2016 in this figure. Wow, a big change. And where's the biggest warming? Right over the Arctic. And if we add a few more years to this, I could have updated this figure, it's even more pronounced. So Arctic amplification, there it is. Wild cards now that people started to think about. Could the Arctic warming be related to weather patterns beyond the Arctic? The issue here is, if you think about how the weather pattern works, it's that we have a colder Arctic and a warmer mid and lower latitudes. And that's because the sun doesn't shine as strongly in the Arctic. That's why it's cold. So you have a big temperature difference in the surface and in the atmosphere. But that temperature difference is what really drives our weather. And what that temperature difference gives us is concentrated in particular regions and gives us our jet stream. That polar jet stream that separates the cold Arctic air from the warmer air to the south. Well, if we warm up the Arctic strongly, basically you're messing with that temperature gradient from the equator to the pole. And the argument is, can that actually change the jet stream? And if it changes the jet stream, that's going to do things like change the tracks and intensity of the mid-latitude storms that we're all so familiar with their warm fronts and cold fronts. Well, very interesting stuff. It still remains controversial. There's scientists who are saying, absolutely, this is already happening. There are some saying, no, maybe it isn't. I think the general view now is, yes, there's an Arctic influence, but it's unclear how strong it is compared to other things like tropical sea surface temperatures. But it's one of these wild cards out there. Permafrost carbon cycle feedback. All right, we know that permafrost is warming and thawing, but one of the issues is that in that permafrost, there's all kinds of carbon locked up in old peatlands and things like that. But if we warm up that permafrost, we warm up the climate, we warm up that permafrost, it starts to thaw. The organic soil, what happens is the microbes in the soil become active. They start to eat that carbon. What do? They breathe out carbon dioxide or methane, depending on the situation, increasing the atmospheric load of those greenhouse gases and resulting in further warming. Big questions out there. When might this kick in? And if it kicks in, how strong is it going to be? Is it going to be a minor effect, or could it be a much bigger effect? This is one of the things that so many scientists are working on now to understand what could be happening now. Well, this goes way beyond climate change, right? Because as the Arctic loses its ice, it starts to become more accessible. Right? Oil, natural gas, mining of all kinds, right? Fisheries. The U.S. Navy, for example, is very well aware of what's happening in the Arctic and recently put together a new roadmap, actually it was some years ago now, 2014, to provide the guidance necessary to prepare the Navy to respond to future Arctic region contingencies, et cetera, et cetera. But, I've talked to some of these Navy guys, and what they told me is that we don't care why the Arctic is losing its sea ice. What we see is there's a blue ocean that I didn't have before, and I got to deal with it. Right? Well, it goes a long ways. I mean, you lose the ice cap, you lose the sea ice. Are we saying now that we have shipping routes opening up? That's through, really, we're talking about the northern sea route along the Russian coast. There's been a lot of talk about the Northwest Passage through the channels of the Canadian Arctic archipelago. But as a potentially commercial shipping line, it's seasonal anyhow, the northern sea route. So in other words, you have a boatload of Toyotas, Priuses, and instead of having to, and you want to get to New York City and, apart from, instead of going through the Suez Canal or the Panama Canal, whatever you need to do, you go right across the Arctic Ocean. Well, unclear. Maersk, a little while ago, they sent their first cargo ship through the northern sea route. Now they said, well, we don't see it as really a commercial route. It's experimental sort of thing, but they seem to be changing their mind. We had the longest ice-free season on the northern sea route ever observed this past summer. We'll see. Could it become a mini Suez Canal or something like that? We'll see, but that starts to raise issues of sovereignty and things like that and national defense. Tourism. Well, I mentioned the Northwest Passage. Here we are. Here's the route that you can take through the Canadian Arctic archipelago. There's actually a number of routes you can do. It was first conquered by Roald Amundsen back in the early part of the 20th century. Yes, he conquered it. He conquered it, but it took him and his hardy crew 2.5 years to do it. Well, back in 2016, 2017, the luxury liner Crystal Serenity went through in like a week and a half or something like that. Raise awareness of Arctic change, something like that. You know, berths were going for something like 40,000 a pop or something like that. But the Arctic is still variable, and the ice is still variable. In 2018, they didn't do it because it was too much ice. But I hear they're having some economic issues. Maybe it's not still viable at the time. But it just goes to show you, you know, what's been happening. You look at this ship, you know, 68,000, 67,000, 69,000 gross tons, 820 feet. I mean, that's getting towards aircraft carrier size, right? 13 decks, 25 knots. Yeah, we'll see what happens in that case. But I mentioned, you know, issues of oil and natural gas. This is from a USGS study done back in 2008. It's just showing where there's supposedly a lot of oil and gas. And of course, oil and gas tend to be found in the same areas. Here's Alaska. Here's the North Slope. Of course, there's been drilling up on Prudhoe Bay for a long time. Production is dropping. But what about out here in the Chukchi Sea, right? And Royal Dutch Shell went out there some years ago. They said they didn't like what they found, and maybe they'll be back. Depends on oil prices. But if you look at a lot of it, it's on the Russian side of the Arctic, right? And Russia is really producing what they've got out there. Big new operations. But these things are raising, you know, some tensions. Questions: will the United Nations Convention Law of the Sea, does that hold? Generally, it does. But there's a lot of discussions going on, and these are key issues that are being discussed by organizations called, for example, like the Arctic Council. Russia, as I mentioned, really taking advantage of these things. Russia has a very, very big icebreaker fleet. It makes sense. They've been operating along the Northern Sea route for a long time. But really, in some sense, exerting its muscle, right? Wanting to have that strong role in the Arctic. They recently launched the new Arctica. It's actually operational now. They had some teething problems, I guess. There's the old Arctica. Now there's a new Arctica. I mean, this is the most capable icebreaker in the world. I think it's like 130 meters, something like that. But it's got 2 nuclear generators, right? It's nuclear powered. U.S. has nothing like this. Canada has nothing like this. U.S. is building a heavy icebreaker. It's going to be conventionally powered. Only the Navy operates nuclear-powered vessels. But Russia, you know, very capable and continue to be very capable, and really is taking advantage of the changing Arctic. So, you know, the changes we've been seeing, good or bad, right? Well, it depends on kind of your point of view here. Now, I haven't talked at all in this talk about, you know, issues like what's happening to polar bears and seals and things like that. You know, I've been really focusing on the climate issue here. But, you know, I think it was important to illustrate here how in the Arctic, issues of climate change and geopolitics are just becoming so intimately intertwined. There's a lot of doctoral dissertations on this sort of thing. I'm sure there will continue to be. So to end on this, you know, in the grand scheme of things, those 2 little ice caps that I became so familiar with back in the early 1980s as Ray Bradley's grad students, I mean, in a sense, they're inconsequential victims of the melting Arctic, a drop in the bucket in terms of sea level rise. If you didn't know they were there before, maybe you'd never miss them. But to me, that loss was personal. And it was one of the things that really, you know, made climate change and what's happening in the Arctic my passion for so many years now. Maybe I'll get up there someday and see what's left. I know there's a cairn up there that we built. Still got a half a bottle of Jameson Scotch, I believe. But I think they really still deserve at least a decent burial. So with that, I'll stop and thank you very much.
Thank you very much, Dr. Serez. We've got people tuning in from all over the world. We've got UK participants all across Canada. We just had someone come in from Whitehorse in the Yukon, all the way in Dunedin in the University of Otago in New Zealand. So welcome in from across the globe, everyone. We've got about 10 or so minutes for some questions. So if anyone does want to share questions in the chat bar, please do. I'd love to see your queries and share them with Mark over the next little bit. But I'll start with, with this changing Arctic, you mentioned that there's a lot of PhD theses being done on this topic right now. Is there more funding? Are you seeing from governments, from universities around the world, just an enhanced desire to understand this changing Arctic and pushing researchers up there, more activities happening or not?
Well, I think with the new administration, we're going to be in better shape. We've been doing okay. Funding has been kind of flat, but the United States needs to take a much stronger leading role on the issues. The United States is one of the 8 Arctic nations and is part of the Arctic Council, but the United States has shown very little leadership recently, much to the chagrin of others. Now, that's kind of, in the sort of geopolitical governance issue. But in terms of the research area about what is happening, we've been okay, but I think we'll be doing better under this administration. It's interesting, like from my perspective, what I see, and certainly in my research, is that I've started to go beyond what is happening to starting to understand what are the impacts of these changes, right? In terms of the environment, in terms of the wildlife, and in terms of the impacts on the people. So my own research agenda has changed a little bit, and you're starting to see much more interest in this impact side. But we'll see. We have long known that as climate change take hold, it's Arctic where it's going to be seen first. The Arctic is where it's going to be pronounced. And that's exactly what is happening. And we should be studying this because it's telling us a story.
Well, I'm going to follow up on that idea of your own research being more vested in the changing impacts in the Arctic. What are you specifically working on right now? Like, what if we were to go to your website and look up the project of the day?
Well, a big issue that I'm working on right now, we're still kind of setting up our website, is rain on snow events. Now, what we're talking about here is you're out there in the winter or something like that, and you get rain on an existing snow cover, and then it gets cold after that. And so you can leave these nasty, hard, icy crusts, which interferes with foraging. And there have been a number of cases where you've had something like massive die-offs of reindeer, of 40,000, 50,000 at a pop. There's evidence that these are becoming more common, but this is something that's having really big impacts. And so we want to understand better, what are the conditions that give you these rain on snow events, particular weather conditions that give them, and what are their impacts? So this is very much an international study where we have one focus on the physics of these things, right? How they form, things like that. But a whole nother side of this is on the impacts, where we're working with reindeer herders, for example, directly on this to try and understand what is happening. So that's another example. That's one example of what I'm doing.
That's an excellent example and leads so nicely into the question we just got from our viewer in Whitehorse, which is something that we've touched upon in a few of the other Arctic Institute talks, which is how do you collaborate with Indigenous communities or elders to inform the research that you're doing specifically, or do you see this across other research labs around the world?
Well, I think this is a very active area in the Arctic. It needs to be done carefully. There's some tendency, as all of these things. Okay, we're here funded by National Science Foundation from the South, and we're here to help you. And that doesn't necessarily resonate very well. It really takes a lot of trust. And trust is not something that happens built in a day. It takes trust. And that takes long-term commitments, takes long-term relationships. But what we found is that that we have to partner this way through what we call, data or knowledge co-production, that we have different ways of looking at the world, and we need to bring those together so that we can really understand these sort of issues. This sort of rain on snow thing, I think, is a perfect example of that. We as scientists can say, well, this was a particular meteorological event that had these attributes, but that's really not solving the problem.
That was a very thoughtful answer, and this is something that we've heard from a lot of the people tuning in on YouTube. Your presentation was very well liked, Mark, so thank you for all our feedback in on YouTube as well. What to ask next? So you highlighted your own research, you highlighted where people are able to check out some of the work that you're doing, and I will bring this up on a banner. If you want to see Mark's webpage on the National Snow and Ice Data Center, it's now linked on the bottom of the page, so do check that out. What other labs or what other resources would you recommend to people? If people wanted to find out more about the changing Arctic, is there any either popular books or research work that's being done that you particularly highlight?
Yeah, well, of course, if you go to our center, you can learn a lot about what's going on in the Arctic. University of Washington is very active. I think you might want to look at something called the International Arctic Buoy Network. And what this is buoys that they've put out in the Arctic Ocean for years and years now, which measure temperature and precipitation and temperature and ice thickness, things like that. That's a good resource. I would just look at the Polar Science Center. Probably if you just Google on Polar Science Center, University of Washington, that would take you there. And then, of course, UAF, University of Alaska Fairbanks, has long been a leader in this sort of thing. So I thought if you just Google University of Alaska Fairbanks Arctic, something like that. But of course, all over the world, in Canada, there's all kinds of work going on, like University of Manitoba and Winnipeg. A number of my colleagues work there. Now, the one thing I think is really remarkable is that there is so much international collaboration in the Arctic. We get along with everyone. Everyone kind of gets along. And we sometimes think that maybe our elected leaders could take a little lesson from observing what happens when we have Arctic researchers get together. We get along.
It's really funny that you mentioned that. Whenever we have the chance to feature Antarctic or Arctic researchers or people that go up to the International Space Station, that seems to be the pervasive message that if we all just adopted those policies, it would be a lot better. And I certainly think there's a strong case to be made for that. Mark, we're wrapping up with time here. So what I want to do, I couldn't get all the links up to all the universities you highlighted, but hopefully people that tune in can listen back and find those out. I will bring up the Buoy Project. So if people want to check out the Buoy Project site, it's right below me right now. The Arctic Institute of North America at the University of Calgary is helping make this presentation possible, so I've got their link up. And one thing happening right now that we featured a lot of programs on is the Mosaic expeditions. This is researchers from all around the world, including many from the University of Colorado. So if you want to check it out, it's currently locked in the ice in the Arctic. Many legs, some really top-notch research coming out of that. So thank you for sharing all those insights. Is there a last message you want to leave us with, this audience from around the world, about Arctic research and what the next few decades might bring?
I just want to say the Arctic is telling us a story, and we need to listen.
Well, thank you so much, Dr. Serres. I hope you have a wonderful class coming up soon, and thanks for spending some time with us today. I really appreciate it.